this video, we are going to learn how to sketch polynomials. So let's take a look at some things first that's going to help us. For linear functions, the parent function is x and the degree is 1, and they look something like this. So this is what y equals x looks like. For quadratic functions, the parent function is x squared, the degree is 2, and the parent function looks like this. For cubic functions, x cubed is the parent function, and the degree is 3. And those typically look something like this little squiggle. There's x cubed. For quartic, we have x to the power of 4 for our parent function, which has a degree of 4. And it will look very similar to a quadratic, but it's a little bit wider, a little bit more square. And for a quintic function, x to the power of 5, degree is 5. And once again, it's going to look kind of like x cubed, but it's going to be a little bit wider, a little bit more square. Okay, so what I want you to notice is that when I have an odd degree function, 1, 3, 5, the ends of my graphs are pointed in opposite directions. They're odd like that, which means that for my even degree functions, they are even. They go in the same direction. This is going to be very helpful for us as we start to sketch polynomials. So there's one more thing that we have to pay attention to, and that is the leading coefficient. So before, with all of our parent functions up here, they all have a positive leading coefficient. So let's start with that. If I have a positive leading coefficient, but an odd degree, odd means they'll go in opposite directions, and the positive means they'll have that positive kind of slope right there. For even, I know they'll both be pointed up in the positive direction. So for odd degree with a negative leading coefficient, the odd means they're pointed in opposite directions. It will just have a negative slope this time. For even, once again, they are still pointed in the same direction. However, they are pointed downwards in the negative direction. So let's practice. Here I've got negative x cubed plus 4x. The degree of this function is 3, and the leading coefficient is negative. The odd degree means that I should have opposite direction. Negative means they should have negative slope. So here's what my ends will look like. Next, we have 2x to the 4th minus x. The degree is 4. My leading coefficient is positive. Even degree means they'll be pointed in the same direction. Positive means they'll be pointed upward. So something like that. For number 3, I can't quite decipher my degree yet. I do need to add all of my exponents together. I have x, which has a power of 1, plus a 5, plus a 3. So 1, 5, and 3 adds to 9. The degree is 9. The leading coefficient out front of x is positive, so 9 is an odd number. They'll be in opposite directions and they'll have a positive slope, so they'll look something like this. Okay, we have one more thing to talk about, which is multiplicity. So the multiplicity of a 0 is going to tell us some more specific details about how the graph looks. If you have an even multiplicity, so if you've got a bunch of factors, you have an x squared, and x minus a number to the power of 4, so let's say we have x minus 2, the quantity of x minus 2 being squared. Because of this even exponent, let's go ahead and graph it. So I'd have a 0 at 2. What would happen is, because of this even exponent, is it's actually going to bounce. Bear with me, it bounces off of the x-axis. So at that 0, it's going to go boing, and it's going to bounce off. So we're not sure what it's doing before, it just depends on the function. But when we have an even multiplicity, it's going to bounce. So that means if I have an odd multiplicity, so something like x minus 2 cubed, the odd exponent means that it's going to cross at that 0. So if I have x minus 2, I've got a 0 at 2, it's going to pass through the point. And we're not sure what it's doing at other points, but at that 0 exactly, it will cross. So let's put this all together. So here I have 2 times x minus 1 to the power of 2 times x plus 2. So I have 2 zeros here. And I'm going to go ahead and write them down. So I have 1, I have negative 2. 1 has a multiplicity of 2, so it's an even multiplicity. So it's going to bounce there. And I have x plus 2. Technically, that has an exponent of 1, which is an odd multiplicity. So it should cross at negative 2. Before we carry on with sketching, we also should go ahead and take an estimate for what the ends of our graph will look like, the end behavior. Well, we need the degree. This has a degree of, we got 2 plus 1, which is 3, and the leading coefficient is 2, which is a positive number. So we should have, because of this odd degree, should be in opposite directions, and the positive means positive slope. So they should look something like this. All right, so let's put all of this together. The first thing I'm going to do is I'm going to plot my zeros. So I have zeros at negative 2 and positive 1. So negative 2, I'm going to label it negative 2, positive 1, about there, label it 1. And now what I'm going to do is I'm going to take the ends, and I know that at 1, it should go up, and at 2, it should go down. Okay, now let's go ahead and take a look at my little notes here. I know at 1 it should bounce, and at negative 2 it should cross. So negative 2 it's going to cross, 1 it's going to bounce. And so that is about, and it is about, it's very rough, but that's about what my polynomial should look like when I graph it. All right, so let's keep practicing. Okay, so I'm going to go ahead and make myself a little table here. First, I'm going to write down the 0. So at negative 2x, that would have to be 0. X minus 2, so 2. X plus 1, so minus 1. Okay. Negative 2x has an odd multiplicity, so it should cross. I'm going to put a C for cross. 2 has an even exponent, which is 2, so it should bounce there. And negative 1 has an even exponent, 2, so it's going to bounce there as well. Let's go ahead and sketch our end behavior. The degree of this function is 1, 2, 3, 4, 5 if I add all the exponents together. And the leading coefficient is negative. Okay, so odd means opposite directions, negative means my lines have a negative slope. So it should look something like that. Okay, time to put it all together. My smallest 0 is negative 1, so I'm going to graph that first. Negative 1. It crosses at 0 as well, and then it crosses at 2. It technically bounces at 2, but I have a 0 at 2. All right, I'm going to put the ends on my graph. I know at 2 I've got the down, negative 1 I have the up from the ends I found before, and now it's time to sketch. Okay, negative 1, it should bounce. 0, it should cross. 2, it should bounce. There we go, we've got our sketch. Okay, one more. I've got 1, 2, 3, 4 different zeros. Let's extend that a little bit. Okay, I've got 2 with a multiplicity of 2, so this should bounce. I've got negative 2 with a multiplicity of 3, so this should cross. Negative 1 with a multiplicity of 2, even, so it bounces. X minus 3, so 3 with a multiplicity of 1, so it crosses. The degree of this function, let's add up all the exponents. 2 plus 3 plus 2 plus 1 is 8. And the leading coefficient is positive. 8 is even, so they're pointed in the same direction. Positive means they're pointed in the positive direction, so they're pointed up. Okay, so it should look something like that. Let's go ahead and put our zeros on the graph. I have -2, -1, 2, and 3, roughly. Okay, I'm going to sketch my ends. Up, up, and time to bounce and cross. -2, I have that it crosses. -1, it bounces. 2, it bounces. 3, it crosses. And there you have it. Thanks for watching.